Should we start? Okay. Good morning, everyone. It's really, really exciting to see you all here. This is a session on Azure Cosmos DB. My name is Rima Nemi, and I'm an architect on the team. Just to give you, a very brief intro of who I am. I've been with Microsoft for about 10 years. I have started out at Microsoft Research, and after some time, I wanted to have more impact on the actual products. So I moved to the product team, and I have worked on SQL Server, SQL Data Warehouse. I was the original founder of the Poly-based technology, which connects the world of big data with relational databases. And now I am on to something new, Cosmos DB, which is our globally distributed database service. So it gives me a great pleasure to talk to you about this after we announced it today. It's been a long journey that started in 2010. I was not there at the beginning, but I joined as soon as I could. And so what is Azure Cosmos DB? Let me play a quick video. Can we have the audio, please?
That puts data everywhere your users are. It seems intuitive, but most databases are still light years away from true turnkey global distribution. Azure Cosmos DB offers the first globally distributed multi-model database service for building planet-scale apps. It's been powering Microsoft's internet-scale services for years, and now it's ready to launch yours. Only Azure Cosmos DB makes global distribution turnkey. You can add Azure locations to your database anywhere across the world at any time with a single click. Azure Cosmos DB will seamlessly replicate your data and make it highly available. Azure Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the throughput and storage you need, anywhere in the world at any time. As the first and only schema-agnostic database, Azure Cosmos DB automatically indexes all your data so you can perform blazing fast queries. And since no data is born relational, the multi-model and multi-API capabilities remove the friction, allowing you to build with any data model and API. While most database services force you to choose between strong or eventual consistency, Azure Cosmos DB provides multiple, well-defined, intuitive consistency choices, so you can select just the right one for your app. Take off with confidence, knowing Azure Cosmos DB provides guarantees and comprehensive SLAs other databases would never attempt. High availability, consistency, throughput, and single-digit millisecond latencies at the 99th percentile. Your app deserves a globally distributed database service that's out of this world. Welcome.
So this is Azure Cosmos DB. In the next 1 hour, I will go through every single core value proposition, and we'll just massage a little bit and talk a little bit more in depth about it. So it was designed as a database for planet-scale apps. And this is what a typical app activity may look like. Depending on where you are, what your business is, where your users are. You could be potentially located in North America, but most of your users could be in Asia. Most of your growth could be in North Europe or whatnot. So this is sort of the big picture, the motivation. If you want to go and build an app, you could potentially start out in one particular geographic region, but over time, as your application gains more and more in popularity, you should be able to elastically scale out both your storage and throughput. You should be able to go and serve the users locally the data where they're present. So Azure Cosmos DB, one of the key differentiators and one of the core capabilities that it provides is the turnkey global distribution. So as you saw me today showing in the demo early in the morning, basically you come to a map that is inside Azure Portal, and you see all of the regions on the map, and all you need to do in order to add or remove a region is basically select it and then click Save, and the data will be seamlessly replicated there. So it's a globally distributed service built from the ground up. Internally, it has a classification. It's called the Ring 0 service. So Azure today has about 38 regions, I believe. That's the latest number. So internally, the services are classified based on the availability, where they are in the regions. Being a Ring 0 service means whenever we roll out a new region, Azure Cosmos DB will be automatically there. So as Azure grows, Cosmos DB will, by default, grow as well. We provide automatic multi-region replication, so you can go and associate any number of regions. You can start out with one, you can start out with a number of them, and you can add and remove as you want them. We also provide policy-based geofencing, so you can actually specify that, for instance, a particular region, only a particular set of IP addresses can access, and you can isolate it if you're, for example, there are regulations or restrictions that you want to make sure that that data stays where it is. We also enable multi-homing APIs, and this is very, very powerful capability. So as far as your application is concerned, as you're adding or removing regions, you actually don't need to do anything else. We will take care of basically routing the requests to the data wherever they need to be. So if you start out, for instance, with 30 regions, but then after a while you need to take down 5, your application will continuously stay available and will be able to serve the data to the customers. We also support both manual and automatic failover. Another unique capability that Cosmos DB provides is actually you can simulate the failover. You can also, so for instance, if you're trying to test out how your application will react in case a disaster happens, you can actually simulate a failover, and we give you 100% guarantees that no data will be lost, and you can just see what will happen. Another very, very powerful capability is actually, as you create the regions and you populate the regions with data, you can associate priorities with those regions. So if a failover actually happens, the failover will happen in the order of those preferences. So this is the snapshot that I've shown earlier today. You can come to the portal, or with a single API call, you can actually allocate where the data needs to go. It's available in all the regions. We have multi-homing APIs, and we provide the automatic and synchronous multi-region replication. So another key core value prop of Azure Cosmos DB is that it's the first service that allows you to horizontally scale out not only storage, but also throughput. So again, on day one, your application is starting out small. You're starting with a few gigabytes, maybe a terabyte of data. But as your application is growing, as the number of users are growing, your data is also growing with it. So it's from the ground up, it's built as a scale-out database service. So not as a scale-up, like most of the relational databases are, but literally taking advantage of distribution property and sharding the data all across the globe. Also, in addition to the storage, as I mentioned, we also provide the scale out of the throughput. So again, you can go and scale it out from a few hundreds of transactions per second to millions of transactions per second. And you can do it actually dynamically. You can create almost like a policy. So for instance, if your application is running globally for different regions, you can actually allocate different number of throughput. For instance, if it's daytime in Asia, but it's a nighttime in the US, you need to adjust the throughput accordingly, because your application will get a different number of requests, and you'll have different rates. So you can actually have a very, very fluid system where you adjust the throughput rate based on the time of the day, based on the geography, and do it very, very elastically. So as I mentioned, throughput and storage, the scale out, it's completely independent. You can scale it worldwide on your terms, go from gigabytes to petabytes. So this is an example, this is North America. So at 9 p.m. Pacific, you need less throughput on, around Chicago area and more on the West Coast. And then it could change later on. So you can actually dynamically adjust it. And you only pay for what you need. So it's a provision-based system. You provision how much throughput you will need, and then you run with it. So another core capability that Cosmos DB is the guaranteed low latency. So all of the reads and writes are served from the local region. Again, your application doesn't need to take care of it. We will do it for you. We give you guaranteed millisecond latency worldwide. So I put here in the table roughly, the reads and the writes. And these are the benchmarks that we're running. So for instance, if you have 1 kilobyte of data, at the 50th percentile, we can serve it to you for the reads in less than 2 milliseconds. But we give you the SLA for the 99% of the requests. We'll give it to you under less than 10 milliseconds. And the same thing is for the index writes. So one of the things is the engine is a write-optimized engine. We use state-of-the-art latch-free database indexing techniques. So there's no lacking, no latching to make it really write-optimized and do the ingest very, very fast. It's an SSD-backed storage, so random reads and random writes are served very, very quickly. And we do also automatic indexing. So this is another core differentiator compared to, for instance, relational databases, where when you come in, you have to define a schema. Then once you put your data in the database, you have to identify what are the indices and the physical, what should be the physical design structure in order to be able to optimize it for the workloads that you're running. In Cosmos DB, we took a completely different approach, and we said, we don't want customers to deal with that. We just want them to store the data as is. We will automatically index everything. So in that respect, whatever your workloads you are running, we'll take care and make sure that they're all very fast. So another fundamental difference is that we looked at how the applications are being built, what type of data customers are dealing with, and we said, well, who wants to store their data like this? And again, that's a completely opposite approach from, for instance, relational databases. Fundamentally, the belief here is that no data is born relational. It's born dirty, messy, in whatever shape or structure it is in, depending whether it's created manually or automatically by the IoT devices. So the idea here was we'll store and support any type of data in whatever shape or form it comes from us. So this is where another approach, kind of the key differentiator for Azure Cosmos DB, is that we are going to be a multi-model and multi-API system. So today we are supporting key value, document, and graph data models. And as far as the APIs are concerned, if you want to use DocumentDB API, you can go ahead and do it. And DocumentDB API includes both SQL language and then the JavaScript. So you can create stored procedures, you can create user-defined functions, you can create the transactions as well. If you want to use Mongo, you can also go ahead and use Mongo. At Strata in March, we just GA'd MongoDB API. And today at Build, we're announcing a public preview of tables and Gremlin Graph APIs. I'll talk a little bit more about these later in the talk. But the table API basically corresponds to the Azure Table Storage. So those of you who have been using that NoSQL service, this is the API that we took, and we actually put it on top of the Azure Cosmos DB infrastructure. And Gremlin Graph is a pretty popular Apache Gremlin API based on the Tinkerpop framework and the Gremlin Graph API for working with graphs and querying. And I'll talk a little bit more about it later on. So fundamentally, basically, the key things to remember here, Azure Cosmos DB is schema agnostic, so we don't require you to specify any schema. You don't need to specify any indices. It's automatically provided for you. It's a multi-model and multi-API system that is running at global scale. So another subject that I wanted to talk about is the multiple well-defined consistency models. And I briefly brought it up in the demo this morning. So this is, again, I don't know how many of you are familiar with the CAP theorem. It's all about the CAP theorem. So when you're building a globally distributed application, think of it this way. Your data replicas are spread across the globe. And if you want to serve data consistently, it's also called like perfect consistency. You have to make sure that all of these replicas agree with each other. It's like a quorum. So that requires some synchronization. It's a distributed protocol. That takes time. And so if you want that consistency, you got to pay it with respect. You have to pay for it in time, and you also have to pay for it in dollars and cents, because it takes the data movement and it takes the resources, computing resources, in order to do that. So that's on the one hand. And if you're building, for instance, a financial transaction system where you need to make sure that people are not withdrawing money from their bank account and they actually have those funds, it makes perfect sense to have a strong consistency. Now, on the other hand, most of the NoSQL databases sort of went to the other extreme. And they said, we're going to focus on the performance, and we're going to make sure that in this globally distributed setting, we're going to run super, super fast. But we're not going to give you any guarantees about the quality of your data. Some data may be stale, some of it may be already consistent, but we're not giving you any guarantees. So in that respect, you're almost faced with these two extremes. Do I want strong, consistent data, but pay really severe price in terms of the performance of my application? And remember, here we're talking about global scale, not just data distributed within a data center. This is distributed across 45,000 kilometers, that's the diameter of the globe as far as I remember, or 26,000 miles. So this is like the speed of light travel. Do I want to pay that price? If my application requires that, then I might not have choice. But we believe in giving more choices to the developers. So what we've done is we've taken 50 years of distributed systems research and distilled out of it a set of intermediate consistencies that developers can go and sort of fine-tune that trade-off between performance, high availability, and how much consistency you want for your data. And so this is the picture that I was talking about. Most of the choices today with other database systems is red pill versus blue pill. Do you want strong consistency but high latency, or do you want eventual consistency with low latency? So we sort of get away from this blue pill, red pill, and give you a set of 5 well-defined consistency models. So it goes from strong, bounded staleness, session, and today at Build we're announcing a new consistency level called consistent prefix, and then eventual. So from left to right, you go basically to lower latency, high availability, and better read scalability, but at the price of the consistency. So this is how do you navigate the CAP theorem? In some sense, you can think of it, sometimes the CAP theorem basically says, when you're faced with consistency, availability, and partitioning, which means basically network failures, which are inevitable in this globally distributed setting, the failures will always be there. You can't get away. So then you have to choose between consistency and availability. With this slider, Cosmos DB allows you to behave like relational databases with strong consistency or like NoSQL databases. So you pick where you want to be or if you want to be in the middle. One of the most popular, and so actually, if you come to the portal, you basically select whichever consistency model you want, or you can go actually and do it programmatically through an API. The interesting thing here, so we've been running it internally for a number of years, and we're collecting the telemetry on how the developers are using consistency levels, what are the benefits. So I can give you the metrics. We've observed that 3% use strong consistency, 4% use eventual consistency, and everybody else is in the middle. So that's a very strong customer signal that there is a lot of value in these intermediate consistency levels. So the next I wanted to play a video by Leslie Lampert. Leslie Lampert is a Turing Award winner. Those of you who don't know what it is, it's like a Nobel Prize in computer science. He had a huge impact on how we developed this system. And so I wanted to play a video, him describing the foundations of the Cosmos DB. Can I play the video, please? Maybe.
Hello, we're here with Dr. Leslie Lampert, the Turing Award winner and world-renowned computer scientist. Leslie's work on distributed systems and TLA+ has influenced and enabled many distributed systems, and Cosmos DB is no exception. Hi, Leslie.
Hello.
Can you tell us a little bit more about Cosmos DB?
Cosmos DB is a database system in which the data can be replicated and copies distributed throughout the world. This permits an application to be configured so every user is near a copy of the data without the application programmer having to worry about how many copies there are or where they're located.
And what are some of the novel contributions Microsoft Research made to Cosmos DB?
My TLA Plus specification language and its tools were used to improve the design of Cosmos DB, helping ensure its robustness. The Cosmos DB team credits TLA Plus with helping them provide great SLAs to our customers. The work of other researchers at Microsoft Research and elsewhere was crucial to developing the 5 different consistency models that Cosmos DB allows developers to choose from. Many consistency models have been proposed in research papers over the years, but to my knowledge, Cosmos DB is the only commercial system that has tried to identify the useful ones and implement them precisely.
And what's the value to developers of having 5 different consistency models to choose from?
Implementing any distributed system involves a trade-off between, on the one hand, the degree of consistency it provides to the users, and on the other hand, its availability and response time. I believe that today, commercially available databases offer only 2 choices: perfect consistency, sometimes called strong consistency, and eventual consistency. Cosmos DB provides 3 additional intermediate choices. I expect that developers will use this flexibility to obtain the trade-off between consistency and performance that they find best for their applications.
Okay, and how did TLA Plus benefit to Cosmos DB?
TLA Plus helped make Cosmos DB a better system in 2 ways. First, it was used to specify the 5 types of consistency that Cosmos DB provides. Consistency conditions other than perfect consistency are subtle. They have usually been described imprecisely, making them impossible to fully understand. Applications developed by designers with an incomplete understanding of the consistency condition they're based on can exhibit really strange behavior. The 5 consistency conditions provided by Cosmos DB have precise TLA Plus specifications, and those specifications will be made available to developers. Second, TLA Plus specifications were written for the core parts of the system. Writing precise descriptions at a high level of abstraction led to a better design, and before a single line of code was written, they helped avoid the kind of concurrency errors that are very difficult to detect by testing. The specifications and TLA Plus tools helped ensure that Cosmos DB correctly implements the consistency conditions described by their TLA Plus specifications.
Okay, and how can people find out more about TLA Plus?
They can find the beginning of a series of lectures about TLA Plus at http://aka.ms/TLA.
Okay, thank you very much, Leslie.
Thank you.
So that's Leslie Lampert, the Turing Award winner and also a researcher at Microsoft Research. So as Leslie mentioned also, one of the core differentiators also, what makes Cosmos DB unique, is the set of industry-leading comprehensive SLAs. So most of the cloud services today give you the SLA on only high availability. We actually looked at it from all of the dimensions and identified what do developers actually really care about. Performance is number 1, so we give you the SLAs on both latency and throughput worldwide. Consistency is another one, again, because of this fundamental trade-off in the globally distributed setting. And of course, the high availability. So all you have to do is basically when you come to Azure Cosmos DB, all of the SLAs are there, and you can actually come to the metrics inside Azure Portal and visualize it on an hour-by-hour basis. What are your actual metrics with respect to the SLAs? And these are all financially backed SLAs, so we really put the money where our mouth is. So Lastly is the security and the compliance. We also give you the enterprise-grade security. One of the latest capabilities that came out also as a part of this release is the encryption at rest. So your data is always encrypted at rest and in motion, again, worldwide. Data index and backups and the attachments, which is basically any rich type of data types like videos, images, and whatnot, is also encrypted. It's also encrypted automatically by default. You don't need to do anything. There is no impact on performance or throughput or availability. It's completely transparent to your application. And also with respect to the compliance and certifications, this is the set. We have all of the latest certifications already in place. Everything from HIPAA to ISO 27001 and SOC 1, SESI 2, and the FedRAMP. So in summary, if you were to remember anything from this session, this is the set of 6 fundamental core value props of Cosmos DB. It's a globally distributed database that is multi-model and multi-API. It gives you millisecond latency, limitless scale in terms of throughput and storage. It gives you a set of 5 well-defined consistency models and the comprehensive SLAs. So that's kind of like Cosmos DB as a summary. Now, to tell you how customers are using Azure Cosmos DB in practice, we actually have a customer here, Johnson Controls. And we have Eric here, who is going to tell you how they're using Azure Cosmos DB. Great, go from here.
Is my microphone on? Can you hear me okay? Great. I'm Eric Paulson. I'm a data scientist / data engineer at Johnson Controls, and I'm thrilled to be here for this big day for Cosmos DB. If you don't know us, Johnson Controls is one of the leading building companies. We make, I'll need that. Thank you. So we are one of the leading building companies. So we make HVAC equipment, we make controls. Oh, I haven't pressed the button. There we go. Here we are. So yeah, we're in the building business, and we make HVAC equipment, we make controls in the building, we make fire detection and security suppression systems, security systems, in energy storage, and then we have a big design and installation business, and we do a lot of service business. So buildings, especially commercial buildings, have been networked for a long, long time, and so Johnson Controls has been doing Internet of Things since long before they were even called sensor networks. Buildings are awash in data, and to make effective use of that, we want to capture all of that data. So here's just kind of an example dashboard of the sort of things that we might capture about a piece of equipment at a site. So we have kind of beyond the structured and semi-structured data, the information about the customer, the specs of the equipment, where the equipment's located. We have other forms of data that we want to capture in the same place. So we actually have multimedia data like images of the equipment, or very fine-grained sensor readings, vibration analysis or ultrasonic analysis that we feed into our technicians want to be able to have access to. We have free-form text from annotations about what the technicians were doing there. And we have, of course, telemetry data from the sensor readings that are all ticked into the same spot here. So having all of this data in one database makes application development considerably easier. This is why we've been very thankful for a system like Cosmos DB, which is our polyglot hub for our IoT data. So as I mentioned, of course, we're using it to store semi-structured data, and the schema flexibility here is really key for us. We are storing data from all sorts of original source systems that we have a semantic translation, kind of a poor man's master data service. So some applications want to read that common schema, and other times they want to get into the original schema, and having that both in the same spot is very helpful. And then again, we have all those other forms of data, and the attachments of Cosmos DB has been super helpful there as well. An important use case for us is freeform text search. We have a lot of data that the users may not know exactly what they're looking for, and having this link to Azure Search has been very, very helpful. And having that integrated search it's let us eliminate a bunch of code from our original system where we were having to keep those systems in sync together. Again, we're using it for all sorts of different access types. So it's super fast, and so it's great for key value stores. Again, the document data for semi-structured data. And then I'm a database person at heart, so having a real query language is fantastic. And then, of course, the benefits of any sort of cloud sort of thing, elastic scale up as needed, and great performance. And I should have emphasized great guaranteed and consistent performance. That's really key for us to be able to have a system that we know we can count on for consistent performance for reads and writes. So I wanted to just quick run through one of our sample services that we've built on top of that. So we have our own stream processing system. We have a system where we have many, many logical streams, and streams may feed other streams. And we decided that it made more sense to build our own processing system. But we have been using Cosmos DB as the underlying storage system for that because it's super fast and well suited for this. The flexibility here is really great. Sometimes we store individual sensor readings as individual things. Sometimes we pack them wide into big tables so you get fast reads out of it. So we've got thousands of equipment, individual chillers out there. Each of them have a whole bunch of sensors on them. So we're puffing plenty of data into our system here. So I'll just quick thought. The global footprint is super important to us here too. So JCI has a presence on all 7 continents. Azure doesn't have an Antarctic region yet, but we have data all over the world, and being able to have this consistent data system available everywhere makes building the applications a lot easier here. So we're thrilled about the global footprint here. So I'll just quick blast through these slides real fast. Just shows kind of how our system works. And I want to give a shout out to the Event Hub team. That's another Azure service that we're a big user and big fan of. So data comes into our system and gets pushed off into through an Event Hub into a system, into a spot where we're going to potentially deduplicate data because some of our sensors send multiple data repeatedly. Then we're going to push the data again through another queue where we're going to write the raw data into Cosmos DB. Our data has downstream feeds to it, so you can kind of think of it as a spreadsheet. New data may cause other data systems need to be updated. So that might mean that we have to read a bunch of other dependent data back out of Cosmos DB and be sent off to an execution engine for computation to be done, and then we're going to write the resulting downstream data back into Cosmos DB. So looking forward, some things that we're really excited about. The change feed notification, which isn't new today, it's been there for a little bit. That's letting us eliminate a bunch of code. The best kind of code is the code you can delete, so we're really excited about that. My security team is really excited about geofencing and geopolicy to help us take care of data residency. Having a system that we can declaratively and programmatically set the policy and letting the system take care of that is huge for us. The graph processing API, we've been really hoping for this, and we're really excited about it. A lot of our data is basically linked graph data, and we do a lot of transitive recursive queries. So other than that, we're just going to keep pushing data into the system and add more equipment and data. So I guess I want to thank you all for listening, and thanks to Microsoft for having us, and congratulations on the big launch, and have a great rest of your build.
Thank you, Eric. Thank you. So I'm going to briefly next go overview some of the capabilities that we're launching today as a public preview inside Azure Cosmos DB. One of them is called request per unit per minute, RU per minute. So this is in preview. So today you can go and provision throughput at the granularity of a second. So you can have hundreds of requests per second or thousands or millions of requests per second. So what we've observed from, again, running the system with our customers is that they wanted to have predictable performance for unpredictable needs. That means once you provision throughput, sometimes it could still happen that you can have bursts. And so instead of throttling the customers when those bursts occur, what they can do is actually they can provision at the minute granularity, And they will be built and basically spread that provision throughput across the minute. So you will use only what you need. It's guaranteed for spiky workloads. And in the production, we've observed for some of the customers, it actually resulted in up to 73% reduction in costs. So this is a very, very powerful capability. We'll publish a blog. We'll also push out a bunch of examples so that you can go and try it out. Another public preview announcement is the support for table APIs. So those of you, many of you probably already in this audience are pretty familiar with Azure Table Storage Service. It's a key value store that is that's basically designed for very quick development. It's very low cost, a lot of simplicity, massively scalable. It's also globally replicated, but number one ask that customers have had was they wanted to have secondary indices and they wanted to have predictable performance. So we've listened to that, and we wanted to provide a premium experience. So basically, you take the table APIs, and you can obtain the same low latency, well-defined consistency, global distribution for table customers as well. And you can get secondary indices for your queries, millisecond latency, basically all the goodness of the Cosmos DB to bring it to table customers as well. So what it means is that as far as your applications are concerned, you can download a premium table SDK, and all you have to do is just change basically the connection string. Your application stays as is otherwise, no changes. And coming soon, we are also working on the storage optimized offer. So currently, Cosmos DB is focusing on this premium experience, throughput optimized, low latency, and this is something in the working also to sort of, again, give you more choices. Do you want to have maybe not as hot workloads and you still want to take, to use Cosmos DB? This is something that we're also working on. The second API that is also in public preview today is the Gremlin API. So this is basically to model very complex relationships between entities represented as nodes and then the relationships via edges. So this graph is a first-class citizen inside Cosmos DB, just like any other data model. We are optimizing for graph storage and traversal, and we're using Gremlin as standard. So the beauty here is that, again, as a backend, you get Cosmos as a globally distributed, elastic, scalable, low latency, and then auto-index service. And we also have a graph engine using basically Tinkerpop framework. And on top of that, we put the Gremlin and the SQL languages. So one of the things that will come in the future as well is the SQL extensions, so that if you do want to query your graph using SQL, not Gremlin API, that will be a capability that will be enabled as well. So to talk about globally distributed graph and how we actually use it in production, let me invite Steven, who will actually give a demo. You're here. And talk how they're using Azure Cosmos DB for graph-like workloads. Thank you. Thank you.
Thank you, Rima, for the introduction, and hello, everybody. I am really excited to be here and share this demo with you guys today. I think you're going to like it and have some fun with it, because it's going to bring to life in a very real and a very visual way several of the amazing features you've been hearing about this morning. I'm actually going to start my demo by having a little bit of fun. We're going to create and customize a graph from scratch and then style it. And then I'll switch gears and talk business scenarios and show how Azure Cosmos DB can be combined with the globally distributed graph to meet real business needs. For all you developers out there, I want to mention that the source code for this is going to be available as part of an open source GitHub repo, and also as part of an Azure Quick Start download. Whichever way you decide to get it, we're going to be providing for you, along with it, a sample data set that you can upload to your very own Azure Cosmos DB. This will give you a rich set of data that you can use to get started exploring the graph quickly. Okay, let's have some fun. Let's create a graph from scratch. This will be somewhat contrived, but it'll illustrate nicely how we support executing Gremlin commands to create and traverse data, and also how easy it is to customize the look and feel of the graph once I've created it. The first thing I'm going to do is create a new collection to store my graph data. I'm going to call my collection family because that's what I plan to have my graph represent. Next, I'm going to add a node to my graph. I'm going to type this first command by hand so you can see what's happening. In order to speed things along after that, I'll be copying and pasting a series of commands. So I can add a vertex to my graph by typing g.addv for vertex. In this case, I've already got it saved. I'm going to add a vertex of type person whose property name is Stephen. Okay, so I have want to save that for a little bit later. Okay, so I've got a single node in my graph, but a graph with just one node isn't very useful or very interesting. So let's add a bunch more. I'll do several at once so that we can move things along fairly fast. Okay. What I wanted to do here was, let's see. Okay, so I've got 5 people and a dog. Actually, let me see. So if I switch back, there we go. Okay, so this is just showing you the default label that comes along with the vertex. These are the types of vertices I've created, people and 1 dog. What we want to do, it was actually already done because I had done it previously. We want to switch over and use the name property. If I had more properties associated with these nodes, you'd see them all here, and you'll see that a little bit later when I use a richer set of data. For now, I just have the 1 property. So these nodes are just kind of floating out there. The obvious thing that's missing here is we have no relationships. Let me make all the nodes. Okay, so there we go. The dog's name is Diesel, and we've got these 5 people. So let's go ahead and create some relationships between the people in this graph. Okay, there we are. Now, I actually wanted to, let's turn that off there. Okay, so here we have some relationships. The graph is starting to come to life. As I hover over an edge, you can see the relationships that tie these nodes together. We have Stephen and Emily showing up as spouses of each other. Stephen is the parent of Anna, Jonah, Julian, and Emily the same. I've also made Diesel have Stephen and Emily as owners. Could have done the same thing with all the children, but let's be honest, do the kids ever take care of the pets? It always ends up being mom and dad's job. Now, let's see. Okay, we should make our family a little more interesting. Let's add some activities to our graph. Okay, so I've added, I got everything saved. I didn't want all of this stuff saved. Okay, so I've got these 4 activities. Where's the other one? There it is. Chasing bunnies, tennis, running, and Legos. But again, we're missing that connection. So I'll connect those things here by adding some sensible edge types. And I wanted to mention, when I add an edge, I'll reveal some of the commands here. I do this with the add-e property. So it's like I added a vertex g.addv. I'm adding an edge with g.addE. I just need to specify the type of edge I want to add and the 2 nodes that I want to connect together. Okay. So I've done that here, and if I rearrange things to make it a little easier to look at, we can see that Emily loves running, Stephen enjoys tennis, Jonah really likes Legos, and Diesel is obsessed with chasing bunnies. Okay, we're almost done. I have 1 more little piece that I want to add just kind of for fun. Okay, so I was gonna, so we have, there we go, makes it a little easier to look at. Stephen as the protector of righteousness and Emily the defender of truth. So what I want to do, after having created all these relationships, you already saw a little bit of it because I had the icon saved. I want to style things a little bit, make it look a little more fun. If I choose a node of type person here, I can select a more appropriate, wrong one. I can select a more appropriate icon for it. Let's do the same thing with activities. I'll choose the soccer ball. And let's see, for Diesel, we'll go with, I know I have paw prints in here somewhere. And finally, let's see, for virtues, let's go with cap. All right, I can change the colors easily on the fly. I mean, it's really, really simple to do. I like orange, so let's go with that. Okay, and then lastly, I'm gonna go over here and turn on edge labels. All right, so now, again, contrived little example, but you can see how easy it is to execute these commands and create a graph that's, very sensible. I have more options to configure this graph. I can make the edge sizes big or really, really big if I want to. I can make the icons large across the entire thing. I can even mess around with the physics that's used to stabilize the graph. I was pretty happy with it the way it was before, so I'm going to go ahead and change it back. And if I want to change edge settings, if I want to make a particular edge pop, like over here, you see that the protector of edge is showing up in lime green. We can do that across the entire thing as well. Okay, so that was kind of a fun, cutesy little whirlwind tour of the UI for our Graph Explorer, and I encourage you to play around with it and try out the quick start, but I want to switch gears now and talk business scenarios. How do we leverage the power of Azure Cosmos DB to solve real business problems, like, for example, fraud analysis? For companies like Microsoft that operate on such a massive scale, dealing with fraudulent behavior is simply a hard reality, but how do we do it quickly and efficiently? If we had a platform that was geo-distributed with low latency, always on, supported massive data sets, and was highly performant, scalable, and customizable, then we could query these large data sets looking for linkages across pieces of information that might suggest a fraudulent pattern. Let me give you a concrete example. Suppose multiple companies are linked to the same Office 365 subscription. This feels a little suspicious because we normally expect more of a one-to-one relationship between tenant and subscription. If we're finding a one-to-many relationship, that might be a pattern we want to pay attention to. Now, when we look at this sample data set, no matter how much I kind of zoom in or zoom out, it's really hard to make sense of the data that's here. Can I execute a gremlin query against this set that will look for the type of pattern that I just described? Let's try it against this sample data set. And this is the same sample data set that you'll get when you try out the quick start that you can upload to your own database. OK. From out of that mess of interconnected nodes and edges, you can see here we've got Contoso 48, Contoso 49, Contoso 50, all pointing to the same enterprise subscription for Office 365 Business Essentials. So hopefully now you're starting to see the power you get when you combine a powerful platform like Azure Cosmos DB with rich visualization. What's the takeaway here? With Azure Cosmos DB, we get a globally distributed multi-model database. As a developer, I don't have to worry about scale or schema, performance, or correctness of data, even at a global scale. I can focus on the differentiation for my scenarios, like business logic and visualizations. Instead of being concerned with tuning the platform, I can light up several rich scenarios in a fraction of the time. I hope you guys are excited to try this out. I have the GitHub repo here. It's Azure Samples, AzureCosmosDB.net. Graph Explorer. It's also available, I think, as of this morning. I'm not sure if I got confirmation, but if you go to the Azure portal and create a new Azure Cosmos DB and I think select Graph as the API, I believe you'll be given a quick start page where you can actually download this exact same sample. And if you go that route, you won't have to populate the config with the information. Azure will know it for you. If you clone from the repo, you'll do that step manually. So give it a try, and I hope you guys have some fun with it.
Thank you, Steve. So there you have it, Azure Cosmos DB. So this is the big overarching big picture. It's a globally distributed service with elastic scale out, guaranteed low latency, 5 consistency models, comprehensive SLAs. And then on top of that, we put any data model, and then we light up with the set of APIs, whether you want to have table API or DocumentDB SQL or JavaScript, MongoDB API, Gremlin API, and more APIs coming. So it's not a big leap of faith to imagine one day you will see a DataStax Cassandra API here, HBase API that gives us a synergy with the open source analytics stack, and even with our friends across the pond, the DynamoDB API and whatnot. So we will basically look for the signals from the developers to see what are the APIs that they're looking for and light them up on top of the stack. So the next step, getting started, visit cosmosdb.com. The portal on Azure, the service is already there. Give it a try. aka.ms cosmosdb, and then if you're looking how to play with the other APIs, Table, Graph, or Mongo, these are the data sources. If you want to also play locally, we have a Cosmos DB emulator. There's a download link for it, so you can actually start developing against Cosmos DB in your local environment without incurring any costs. Revisit the build sessions recordings on Channel 9, and we will have also a class on Microsoft Virtual Academy online. There are a number of also other sessions that are related. NoSQL capabilities, and I believe Eric is also giving a presentation, and then, also Kale, one of our customers, also presenting on how they're using the service. So with that, this is Azure Cosmos DB. We're just getting started. Thank you so much for attending it.